This is the urinary system. Functions of the urinary system are to basically filter the plasma from the blood, excuse me. And what this means is that it's going to separate anything that your body needs from anything that your body does not need. So it's going to eliminate the wastes or toxins or whatnot. It also helps regulate blood volume and pressure. It controls osmolality with the ions of like sodium and potassium and chloride. It functions in the endocrine system with the RAS system, which is the renin-angiotensin-aldosterone system. It helps with erythropoietin, which is a hormone to produce red blood cells, calcitrol, etc. There's lots of these. It also regulates your blood pH with the lungs by removing bicarbonate. The lungs are the ones going to be removing the volatile acids, which are the ones that can be turned into gases really easy. And the kidneys are the ones that are going to be dealing with the ones that do not turn into gases real easy. So it's a little bit slower of a system, but it still works with the lungs to maintain the pH of your blood. The organs of this system are you have 2 kidneys, 2 ureters that drain the kidneys, a urinary bladder, and a urethra. You see in this picture that we have, there's a renal artery going for it. The hilum is this curve right through here. Then you have the vein pulling blood away. There's your kidneys, your ureter, the bladder, and the urethra. Those are the main organs, and the blood supplies going to the kidneys. Excretion. The kidneys are one of the main excretion systems of the body. And there again, it's removing the waste from the bodies. And the most important waste are these nitrogenous waste. And then of those, urea is the main nitrogenous waste that is released or excreted, excuse me, from the body. But the kidneys are a filtration system where they are going to be pulling things from the blood, primarily from the plasma of the blood, and then they concentrate that into urine, which is then excreted. On the kidney itself, you have some main features of it. Cortex is always the outside edge. This region right along here is the cortex. Then you have the medulla, which is the middle of it. And here's your pyramids. You have your major calyx, which is the big region of that where the urine is concentrated. And then you have your minor calyx, which are the smaller regions that are going to flow into the major calyx. And all of the urine will flow from the minor calyx through the major calyx, then out the ureter. You have columns separating pyramids. And those are the major features of the kidney, major anatomical features of the kidney. Now, the filtration portion of the kidney starts with the blood flow going to the glomerulus. So you have blood flow coming in, and there's lots and lots of stuff in here. And the glomerulus is this capsule going around it, and it is filtering the blood. which goes through the proximal convoluted tubules. Proximal because it's closer to the glomerulus. Then you have your loop of Henle, which is, so you have your descending loop and your ascending loop, and there is a little bit of structural difference. The ascending here is a little bit thicker than the descending. Then you'll have your distal convoluted tubule because it's farther away from the glomerulus. And then you have your collecting duct, which is going to go into the minor calyx, major calyx, and ureter. All right. Now, what again, the kidneys do is they filter the plasma. And that's important. It's the plasma. The blood doesn't actually get filtered. It's the plasma, which would, and then there's osmotic pressure that moves things around. And this is going to create urine. Anything that we need, we try to reabsorb through this system. And anything that we don't need, we get rid of. The kidneys do a good job of concentrating urine. Otherwise, we would be, roughly 180 liters of urine a day would be produced. So you're talking about 40 gallons, a little over 40, actually it's more than that, it's about 42, 45 gallons of urine a day that would be produced. So that's a lot of drinking. You'd be doing nothing but drinking water to maintain your hydration if it wasn't for the kidneys doing their job of concentrating the urine. It does this by changing the water amounts in the fluids, changing the concentrations of the ions, and then the final product is collected in the ducts and excreted. It also the kidneys also regulate blood pressure. We mentioned earlier with renin. Renin is one that'll start the blood pressure system with the angiotensin and aldosterone system, which ultimately changes the amount of water that is removed. So it changes the concentration of the urine. By maintaining water in our bloods, in our system, it will help us maintain blood pressure. Because if the water level gets too low, the blood pressure drops. So we're talking about the blood volume then and the water. If we're consuming too much, we excrete more. So then to keep us from having too much volume. And then again, blood pH, mainly by the bicarbonate and the hydrogen ions to concentrate or to maintain our pH. So how the nephron works. First of all, the blood's got to come into, there's a lot of vasculation through the glomerulus. And this is where this extension right here is actually all of the proximal, descending, ascending, and distal convoluted tubules is what they're showing you over here. And at various stages, various substances are absorbed or excreted. And so they're showing you that most of this is reabsorbed through the proximal, and then as it goes through the descending loop, there's proteins or channels that will absorb water. So water gets pulled out, so it's concentrated. As it's flowing back up the ascending, urea is absorbed into the ascending loop, but there's protein, the pores in it do not allow water to escape. So at this point we can pull out, because now it's concentrated, so we can pull out sodium, potassium, and chloride however we need it at this point. And based on aldosterone levels, which is what's going to help regulate the amount of water that is retained or released, excreted through here. There could be various amounts in the distal convoluted tubule, and then it is concentrated going down. We can, again, there's that water being absorbed because of the aldosterone, excuse me, antidiuretic hormone. If we are excreting that, we're going to pull more water out because that means you're dehydrated. If that level's low, then more water can be released, and so forth. But the main thing is that water is going to be collected, reabsorbed through the descending loop, and our sodium potassium chloride is going to be reabsorbed in the ascending loop. Urea, again, is concentrated in the ascending loop. And that's it for the urinary system. Any questions, please ask.